Hello. In this video, we will cover the run modes in GPX using the GPX library project. To open this project, go to the dashboard view and click on the icon next to select to open an existing project. In this case, I already have the GPX library project opened, as you can see on the right-hand side of the GUI, where it displays the project name, and also you can see that all the views are enabled. Before we do our exercise, we will save a copy of this project. To do so, click on the icon next to Save As and leave the copy selected from the Save As dropdown. We will name this project GPX Library Copy. You can click on Browse to select where to save this project, and I will save this on my desktop. I'll create a new folder and call it Library Copy. And then you can click on Select Folder. After doing that, click on Save to save a copy of this project. A pop-up message will appear asking you to make sure that any changes that have been made in the current project have been saved. And you can click Yes on this message. An information message will appear in the Messages Center, letting you know that the GPX library was successfully copied to GPX Library Copy. Click Done to clear the message. We will now move through the views to see the data that has already been entered in this project. Moving to the Observed Data view, we see that 3 different types of exposure data entries have been already created, as well as solubility data has already been created for some of the compounds in this project. Moving to the Compounds view, we see that there are 9 different compounds in this project. You can review the physicochemical properties of any of these compounds by clicking on it and then opening panels to analyze the properties of the compound. We'll skip over to the Simulations view. And from the Simulations dropdown, we can see that there are 9 different simulations created in this project. Instead of running each simulation individually, we will run a batch simulation using the run mode in GPX. For this, navigate to the Runs view and click to add a simulation. To add a run, click on the Add drop-down menu. From the drop-down menu, you can see that we can select different run modes that are available in GPX. In this case, we want to run a batch simulation, so we will select Simulations. We can name our run PO Simulations, and then click OK. To include the simulation, you can either select each toggle or for each simulation that you want to include in your run. In this case, we want to include all the simulations that are created in this project. To do so, click on Select All. As you can see, the toggles under the Include column have turned green, indicating that all the simulations have been added to this run. If you'd like to unselect or not include any of these simulations in the run, simply click on the toggle and it turns gray, indicating that this simulation will not be included in the run. I will click this toggle back on because we want to run a run with all simulations included. We are now ready to run the simulation. Scroll past the Output Settings panel to the Run Controls panel and click Start. The Analysis view will automatically be activated when the run has completed. In this case, we don't want to assess the Key View mode. Rather, we want to assess the Summary View mode. To do so, click on the Mode dropdown and select the Summary View from the dropdown. This will enable us to compare the fraction absorbed, or the FA, of all compounds in this project. We can sort the compound in order of FA by holding Alt on your keyboard and then clicking on the column heading. As you can see, the simulations have been reordered, and we see that the ketoprophene simulation was the one with the highest fraction absorbed. We can expand this panel so we can see all the simulations included in this run. We can also unselect the observed data toggle so that we are not going to see the entries that we have for some of these simulations that have observed data. By doing so, now we are comparing the simulation results of each simulation. We can also sort these simulations for each of these column headings. So for example, if I want to see which simulation had the highest bioavailability, I would click on Alt on my keyboard and click on the bioavailability header. And you can see that the piroxicam simulation had the highest bioavailability. We will continue to explore the run modes in GPX by running an optimization on the brick dust simulation. From the summary view, we can see that the fraction absorbed for the brick dust simulation was about 55%, and the Cmax was about 3.9 nanogram per ml. We're going to optimize the dose such as the Cmax of 10 nanogram per ml is obtained. For this, we will navigate to the observed data view, and we will minimize the profiles panel and expand the parameter panel if it's not already expanded. And you can do this by either clicking on the green arrow or double clicking on the panel header. Find the brick dust PO tablet entry in the table and enter an observed Cmax of 10 nanogram per ml, and then hit enter. We can now save this project by clicking on save and then clicking on OK on the pop-up that says the project has been successfully saved. We will come back to the runs view and we'll click on add to select the optimization run type. We will call it optimal dose and then click OK. Since we just want to select the brick dust simulation, we will simply select the include toggle next to the brick dust simulation name. We will move to the optimization parameter selection, and we will use the search bar to find the dose strength, which is the parameter that we want to optimize. Type STRE and hit enter, and then you can select the box next to strength. Once you've done so, you will see that the table on the right-hand side will be populated with the selected variables to be optimized. Now we will move down to the observation, selection, and weights. In this case, for brick dust, we want to optimize the dose against the Cmax. So you can select the Cmax from the pharmacokinetic parameters frame, and you can also assign a defined weight that you wish to use. In this case, we are going to use a weight of 1. We will scroll down to the Run Controls panel and click Start to begin the optimization. When the optimization completes, the interface will automatically switch to the analysis view and using the optimization view mode. The optimization view displays the initial dose as well as the optimized dose of 31.3 mg. So the initial dose was 10 mg and the optimized dose was 31.3 mg. Next to the optimized value, there is a button labeled transfer. And this button enables the final value to be transferred to the appropriate input field. On the right-hand side, you can see the pharmacokinetic optimization results are also shown, which confirm that the simulated Cmax is around 10 nanogram per ml, or 9.999. We will click Transfer to update the administered dose. Note that a message has appeared in the Messages Center that confirms that the update has been made and highlights in which panel the change has been made. We'll click on Done to clear the message. Now we will navigate to the Simulations view, and with the brick dust simulation selected, we will click on Check Warnings and then run a simulation. When the simulation is done, you can click Switch the view to Summary View to confirm that the Cmax achieved was approximately 10 nanogram per ml. You can also come to the dosing view to see the updated dose that you have transferred. In addition to the results that are displayed in the interface, if we come to the optimization view, in addition to these results that are displayed in the interface, an optimization results Excel file is also generated and saved in the same folder that the project is located. You can also use that file to see the updated value for the parameters that you have optimized.